Hello everyone. So this is Aprajita, your chemistry SME at MEMONEET. How are you all doing? So we are meeting after a long time. I hope all of you are doing good and your preparation are going well. So today I am back with another chapter, that is classification of elements and periodicity in properties. Okay, so this is the chapter of class 11th, and in your next Brahmastra part test, that is in BPT 13, this is the syllabus this chapter is going to come. Okay, so this is a very basic chapter and we have studied a lot of things till now, so it would be very easy for us to understand this particular chapter. Okay, so you already know that in this chapter we study about the modern periodic table, and then we see ki how the different properties vary in the periodic table, right? So that's what we are going to study in this particular chapter. So let us start then. All right, if you are facing any issues during your NEET preparation, or if you are having any problems, you can tell us. Okay, you can comment below in our videos, you can contact us through the Telegram channel, through the WhatsApp channel. Okay, so please be in touch with us, all right, and try to interact as much as you can. All right, students, so today we are starting this particular chapter. All right, so basically we are going to study about the modern periodic table, but before we study the modern periodic table, you know that many attempts were made by different scientists in order to classify the elements. Now the question is ki why the need for classification arise, since earlier not much elements were discovered, so it was very easy to study them. Now you know that there are around 118 elements that we are having, so in order to study them, it is important to classify the elements. So that is where classification of elements is important, right? So earlier also, as more and more elements were getting discovered, scientists were trying to find out different ways to classify the elements. So although we will be mainly focusing on the modern periodic table, but let me give you a very brief idea about the earlier classifications that were made. Okay, so we will just do a quick recap as you have learned about them in your lower classes also. So the first one was Dobriner's triad. Okay, so you already know that Dobriner was actually the first one who tried to classify the elements. Okay, he was the first one who took the step in this journey. So all right, he actually observed some similarities in the properties of the elements. So what he did was he made a group of three elements, okay, which he called as a triad, and in that triad all the elements having similar kind of properties were there, like they were having similar chemical and physical properties. But apart from that, the major point was that in every triad the atomic weight of middle element was the average or half of the sum of atomic weight of other two elements. Now, how that is happening, can you see here? One triad is lithium, sodium, and potassium. So, if I take the atomic weight of first and third element, lithium and sodium, lithium and potassium, sorry. So, 7 plus 23 divided by 2. So, sorry, 7 plus 39 divided by 2. All right, students. So, it will be 46 upon 2 if I am taking lithium plus potassium upon 2. Okay, so 46 upon 2 stands for 23. So that is the atomic mass of sodium. So that's what Dobriner said, that the atomic mass of middle element is average of the atomic mass of other two elements. For example, other triads were like strontium here has the average of atomic mass of calcium and barium, then chlorine, bromine, iodine. Okay, and properties of the middle elements also were in halfway of both the elements. But this method was actually not very successful because he could not classify all the elements present at that time into the triads. Okay, and so that was the main thing in this classification, but it was the first attempt and a well tried attempt, we can say. Next was Newland octave. Okay, so Newland actually gave us the law of octaves. Octaves you might have heard, like musical notes also you have octaves, alright. So according to him, he also arranged the elements in order of increasing atomic weight. Can you see that atomic weight was taken as the criteria earlier for the classification of elements, and this was started by Dobriner. Okay, so octave means here he said can when we are arranging the elements in increasing order of atomic weight, he said that every eighth element had similar properties as that of the first element. जैसे कि musical notes में होता है कि first and eighth note are same, right? So that was the case. All right, can you see, like, if we are talking about lithium, it is at the first position, so the element that comes at the eighth position means the sodium, so it will be having similar properties as that of lithium. Same goes with beryllium and magnesium, boron and aluminium, carbon and silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, like so on. But again, this law was dismissed because it was only valid up to calcium. It was not applicable to higher elements. Okay. After calcium, also at that time, 56 elements were known. But this law was not applicable for higher elements. Means after calcium. Okay. Moreover, in some places he placed two elements in the same position. That was also not correct. So there were certain limitations for this classification also. Then came the major turning point. What I can say is the Mendeleev's periodic table. Okay. So this was actually the real development when this term periodicity or periodic table came into being. Okay, so periodicity, periodicity is something when something is repeating itself after a fixed interval, right? So Mendeleev, he did a lot of research and then he gave us a law which was known as Mendeleev's periodic law. Okay, Mendeleev's periodic law. So he was the first one who gave us the concept of periodic table first of all. So he is also known as the father of the periodic table. Although he did not give us modern periodic table, but still the concept of periodic table and periodicity came from Mendeleev. Okay, so he said that properties of element are the periodic function of their atomic masses. Now this is important. He arranged the elements in increasing order of atomic masses and he found out that the properties of the elements are repeating after a fixed interval. So that is why he said that properties of the element are periodic function of their atomic masses. So he arranged the elements in periods, which are your horizontal rows, and groups, which he called as columns. Means the columns are known as group. Like you can see, they are written in Roman numeral. So according to him, there were 8 groups and like 6 periods he made at that time. Can you see? These are the elements that were present. So this classification was very, very important as it solved a lot of problems at that time also. Okay, moreover, not just he gave the periodic table, can you see there are some gaps? We can see some gaps here. So Mendeleev was so sure that certain elements would exist at these places only that were not yet discovered. Okay, means that were not discovered at that time. तब तक वो discover नहीं हुए थे, but he was sure कि elements discover होंगे. So he named them as A का boron, okay, A का aluminium, means the elements that would be discovered will be having some properties like that of boron or aluminium, and one more was eka silicon, which were later discovered as scandium, gallium and germanium, okay, respectively. So he was so sure and he gave us this thing. So he left some gaps. He predicted the atomic mass of some elements. He actually corrected the atomic masses of various elements in accordance to this periodic table. But again, there were certain limitations. The first limitation was that he could not give an appropriate position to hydrogen, okay, because it had some properties similar to that of the alkali metals also and that of the halogens as well. Next one point was he could not specify the position of isotopes. Why? Because isotopes are the ones which have different atomic masses. Now, if he is arranging the elements according to their atomic mass. Let's say if hydrogen has 3 isotope, so it should give 3 position to hydrogen only according to the atomic mass. So that was another problem, that he could not specify the position of isotopes. And this thing also did not take into account the structure of atom and all of that. So these were the major limitations. And in certain cases, the increasing order of atomic mass was also not obeyed. Means, to keep the elements of similar properties together, he swapped the elements. Can you find here that cobalt has more atomic mass than nickel, but still it is placed before nickel? So that was the thing. Alright, and it happened with other elements as well. So these were certain limitations because of which this table was discarded, or this law was discarded. Okay, but again, it does not mean that it was not important, it was important. All right. So after that, we got the modern periodic law, or the modern periodic table. So basically, students, when structure of atom, earlier structure of atom was not known to scientists. Now some x-rays were studied, many things were studied, and after that, Henry Moseley was the one who gave us the modern periodic law. So he actually modified Mendelev's law only. So he said that physical and chemical properties of the elements are the periodic function of their atomic number. So he actually told that the basis of classification should not be atomic mass, which was अभी तक जो scientists use कर रहे थे, right? But it should be atomic number. Means elements are arranged in order of increasing atomic number. तो क्या होता है? The elements with similar properties are repeated after a certain interval. So based on this law, modern version, that is the long form of periodic table, is used now, in which we have horizontal rows which we call as periods, and we have vertical columns which we call as groups. So in our modern periodic table, we have 7 periods and 18 groups. And the elements which have similar outer electronic configuration, they are arranged in a particular column, means in a particular group. Okay, so they are called as groups or families. All right. And according to IUPAC, like earlier 1A, 1B, 2A, 2B were used, but now the group numbers are used as 1 to 18. We are not using Roman numbers now. Okay. And what about the period number? So period number corresponds to the highest principal quantum number of the elements. Ki how many shells are there? Okay, like first period may we have hydrogen and helium, both of which have one shell only, means their principal quantum number is 1. Okay, second period may the elements which have n equals to 2 will be there. Okay, from lithium up to neon. Then in third period we will be having again 8 elements. Okay, that is we are not considering that transition elements abhi. Okay, so that is the thing. Now we will be having sodium up to argon, right? So that is going to happen in this case. Then we have 18, 18, then 32 elements. So means period number tells us about the principal quantum number of the element, and group number tells us about the electronic configuration. Okay, and the lanthanoids and the actinoids are placed separately. Let me show you the periodic table, you will have more idea about it. Can you see here, students, that all of these elements, these are known as a particular group. Okay, like lithium, sodium, potassium, rubidium, cesium, francium, they are the part of group 1. Then group 2, then these are group 3 to 12, which we call as transition elements. It's the D block. We'll study about the blocks also. Then we have group number 13 to 18. Group 18 represents the noble gases. And lanthanoids and actinoids, they are the part of groups, 6th period and 7th period, but they are placed at the bottom. So this is just an introduction session of this chapter, because when you know about the periodic table, how the elements are arranged and how the things are done, then we can talk about periodicity. Okay, then we will be talking about periodicity in our next lecture. So this is how our modern periodic table looks. Okay, now we will be talking more about the electronic configuration of the elements, the significance of group number and period number, and different blocks. So let us move ahead. So now students, let us talk about the nomenclature of elements with atomic number more than 100. Okay, so actually earlier what was used is that the one that who discovered the elements, because more after 100 atomic number, mostly the elements are man-made or discovered by humans. Okay, so based on their name, the name was written, but again there were certain controversies arising that who discovered the element. So in that way, IUPAC gave us this nomenclature ki till it is finalized that whoever discovered the elements and the name is given, till then we will be using this nomenclature. Okay, and you know we have got one question in NEET examination from this nomenclature also. So do not skip it or think it is not important. Recently this question was asked. You can see in the PYQ book also that the question on nomenclature was asked by the NEET, okay, by NTA. So for digit 0, the word root will be using will be nil, like for one, un, bi, tri, quad, pent, hex, sept, oct, n. So these are the word roots that we are using, and now how to use them. And at the end, IUM will be writing that. Okay. For example, for 101, okay, for 1 we use un, right? Un. And for 0 we use nil. So un, nil, like for 1 0, then again it's 1, then again un will be there, and IUM at the end. So it will become un, nil, niyam. Okay, so this is how you will be writing the names, but its PSC official name is Mendelevium, based on the name of Mendeleev. Okay, in order to honor him, the name was given by the name was given Mendelevium. Okay, so can you see from 101 to 118, these are the names that are given. Alright, it's easy. You just have to remember those word roots that I have shown you, and it would be easy for you to understand. Okay, like this one. So this table you have to remember and make it. Now let us talk about electronic configuration of elements and the periodic table. So if I am talking about electronic configuration of elements in the period, so I have already told you that period indicates the value of n for the outermost or valence shell. Means it tells us about the number of shells in a particular element. Okay. And when you are adding the elements in successive period, the next principal energy level gets filled. Like if I am talking about the first period, okay, so first period may what happens is we have two elements only, because the first shell is filled. Okay, first shell is filled. We will be starting with the lowermost energy. How to write the electronic configuration? For hydrogen it is 1s1, okay, and then for helium it is 1s2. So 1s is filled, first shell is completely filled. Now the second shell will start to get filled. So the element will move to the second period starting from lithium. Okay, so lithium may the configuration would be 1s2 and just a minute, 1s2 and 2s1. So now the 2s has started to fill. So it will move from lithium to beryllium, which will be 1s2, 2s2. Now this 2s is again filled. Now the 2p will start to get filled from boron 1s2, 2s2, 2p1. Okay, then carbon 2p2. So it will go up to neon, which will be having 2s2, 2p6. Now the second shell is also completely filled. So first period has 2 elements, second period will be having 8 elements, okay, because the second shell can accommodate 8 electrons. Now the third period may third shell will be getting filled, okay, by the filling. Ab yahan pe which electrons will be filled? The 3s and 3p orbitals will be filled, okay, from sodium up to argon. Okay, so यहाँ पर it will be 3s1, alright, and then यहाँ पर 3s2, 3p6. So again there would be 8 elements. यहाँ पर भी there will be 8 elements in the periodic table. Let me show you again. Here Can you see first period has only two elements, hydrogen and helium. Okay, they have shown here separately, but again it is placed in the first period only. Then second period has 2s 1 से शुरू होकर 2s to 2p 6 तक, lithium to neon. Third period will be sodium to argon. Then if you look at the fourth period, now 4s and 4p will be filled. Okay, but before filling, when you have this 4s is filled now, after 4s is filled for potassium and calcium, 3d orbitals come. Okay, 3d orbitals starts to get filled. So from scandium up to zinc, 3d 1 से लेकर 3d 10 starts to get filled, and then we will be having again 4p. So in fourth period, 4s, 3d and 4p orbitals are filled, and it will be having total of 18 elements. Okay, so this middle series that starts here na, these are known as transition elements. Okay, we will be calling them as transition elements. Then if I am talking about fifth period, again starting from rubidium up to xenon, so 5s is filled, but for 5s and 5p, in addition to that 4d will be also filled, starting from yttrium to cadmium. Okay, so again this will be your transition elements. It is also having 18 elements. Okay, 2 8 8 then 18. Now if you look at the sixth period, okay, so 6s is filled here. All right, 6s, of course 5d will be filled, 6b will be filled, but in addition to this, now the 4f orbitals comes here, and 4f orbitals are filled in the sixth period from 4f1 to 4f14. So these 14 elements, these are written separately, which are called as lanthanoids. Okay, so total of 32 elements will be there. 14 extra add ho gaye na, so 18 plus 14 32. So 14 elements will be added here. So these are known as inner transition elements or the lanthanoid series. So in sixth period you will be having 32 elements, and so sixth shell fill हो रहा है ना, 6s 6p, in addition to it 5d will be filled and 4f will also be filled. Same goes for seventh period. Seventh period में you will be having 7s 7p 6d, and in addition to 60, 5f will also be filled, and from thorium up to lawrencium, so here it will be filled, and this is also your inner transition series lanthanides, and this one is called actinoids. Okay, starting from actinium. All right, so this is about the electronic configuration periods. You know, in electronic configuration in group, a particular group element will have similar valence shell electronic configuration, means they will be having similar number of elements in the outermost shell. Okay, for example, here we have taken the group 1 elements. So group 1 elements, which include lithium, sodium, potassium, rubidium, cesium, francium, you can see here that all of them are having ns1 configuration. Last shell में there is one electron. Okay, 2s1 3s1 4s 5 6 7. तो जैसे जैसे पीरियड इंक्रीज हो रहा है, शेल तो इंक्रीज हो रहा है, बट ऑल हैव ns1 वैलेंस शेल इलेक्ट्रॉनिक कॉन्फ़िगरेशन, मींस आउटमोस्ट इलेक्ट्रॉन. सेम गोज फॉर ग्रुप 2. ग्रुप 2 में क्या होगा, ns2 होगा. ऑलराइट, इफ आई skip the transition elements, then if I go to group 13, so वहाँ पर ns2 np1 होगा, right? Then ns2 np2 for group 14. Similarly for group 18 it will be ns2 np6 सभी के लिए. So the outer shell electronic configuration is same. Okay, keep that in mind. Now let us see different blocks. Now you can see that the periodic table is divided into 4 blocks, S, P, D, F. Now how this S, P, D, F is actually made? So it depends on the last electron in just a minute. Last electron is entering which shell? Okay, कि last electron किस shell में enter कर रहा है, if it is entering, or which orbital, किस orbital में वो enter कर रहा है. If it is entering the s orbital, electrons you can say the elements belong to the s block. Here यहाँ पर आप देखो, the electrons are added in 3d 4d 5d 6d, so that's your d block. Okay, यहाँ पर पी ब्लॉक में जो लास्ट एलिमेंट एक्सेप्ट हीलियम, ठीक है, हीलियम को अगर हम एक्सेप्शन यहाँ दे दे क्योंकि यहाँ पर 1s2 होता है, बट सिंस इट्स अ नोबल गैस इट इज प्लेस्ड विद पी ब्लॉक एलिमेंट्स इन ग्रुप 18. ओके, सो दैट्स द थिंग. बट अदरवाइज सभी एलिमेंट्स में द इलेक्ट्रॉन्स, लास्ट इलेक्ट्रॉन आर गेटिंग एडेड टू 2p, 3p, 4p, 5p, 6p, 7p ऑर्बिटल्स. एंड सेम गोज फॉर एफ ब्लॉक जो आपके इनर ट्रांजिशन है, द इनर ट्रांजिशन एलिमेंट्स. सो हियर the inner transition elements में क्या हो रहा है, the electrons are adding getting added to 4f orbitals in the lanthanoid series and 5f orbitals in the actinoid series. Okay, so what are the different properties of these blocks? Let's study them. So S block में you have group 1 and group 2 which are alkali metals and alkaline earth metals. So the electronic configuration is ns1 and ns2. Keep that in mind. Okay, you have to keep in mind the electronic configuration. So you know these are reactive metals with low ionization energies because it is easy to remove this outermost electrons. Okay, because easily ये क्या बना देंगे, M plus and M2 plus बना देंगे, means they can lose their 1 or 2 electron very easily. Okay, metallic character, so these all we will study कि trends कैसे होते हैं. All right, so just try to understand they are highly reactive and they are never found pure in nature. Okay, they'll be combined with some other elements. Okay, P block की अगर मैं बात करूँ, if I talk about P block, so group number 13 to 18 is there. So it's NS2 NP1 यहाँ से शुरू होता है and it goes up to NS2 NP6. Okay, from group 13 to 18, these are called main group elements or representative elements. So you know that this NS2 NP6, this is a complete shell. Okay, 8 electrons in the outermost shell. So these are your noble gases. So all noble gases में you know the valence shell is completely filled and they are extra stable, so they have low chemical reactivity. Then we have two important groups, group 17 which is your halogens, highly negative electron gain enthalpy होती है इनकी, and group 16 oxygen family which we call as chalcogens as well. Okay, and they are non-metallic. Mostly these are non-metallic in nature, sabhi nahi but mostly. Okay, because non-metallic character increases as we move left to right in the periodic table. Okay, now let us talk about D block transition elements, group 3 to 12. I told you that here the D orbitals are filled, so n minus 1 D1 से 10 तक होता है and ns2. So D fill होना यहाँ पर शुरू हो जाता है. Like if you are filling 4s orbital ना, तो 3D उससे पहले fill होता है. Okay, so that is the thing. So ns यहाँ पर आप लिख सकते हो 0 to 2. Okay, so zinc, cadmium and mercury, they have fully filled d orbital, d10 configuration होती है. So they do not show properties of transition elements because for transition elements incomplete d orbitals are important, so that's why they are colored and all of that. This we will study when we'll study the D block chapter or the P block chapter. Okay, separately. So this is just an idea about the configuration. So actually transition metals are a bridge between the metals of S block and non-metals of P block. So that's why we call it as transition elements. Then if I am talking about the F block inner transition elements, so there are two rows, right? One is lanthanoids, which is from like cerium to lutetium. Of course lanthanum bhi hoga वहाँ पर, which is above. Then actinoids from thorium up to lawrencium. Okay, so यहाँ पर F होता है, right? F1 to 14 is filled, N minus 2 F1 to 14, N minus 1 D and NS2. So last electron is getting added to the F orbital. That's why we call it as F block elements and they are called inner transition elements. Okay, so their chemistry also we will be studying later on about the F block elements. So they can actually show a large number of oxidation states. Okay, so that's why their chemistry is very complicated. Actinoids जो होते हैं, they are mainly radioactive also. Okay, so and this is about the F block elements. Okay. So this was about, students, the different blocks that we see in our periodic table. Apart from this, you might have seen we have classified the elements into SPDF, but the elements can be divided into metals and non-metals. So metals जो है mainly they are on the left side of the periodic table that you can see in the S block. Okay, so metals, they are usually solids at room temperature except mercury. Okay, गैलियम एंड सीजियम रूम टेम्परेचर पर तो नहीं, बट अगेन दे कैन एग्जिस्ट इन liquids as well. Okay, metals usually have high melting and boiling points, good conductor, malleable. This we all have studied, right? Malleable, can be hammered into sheets, can be drawn into wires, means they are ductile. If I am talking about non-metals, they are on the top right hand side of the periodic table. Okay, so what is happening is that when we are moving left to right, जो non-metallic character है that is increasing. Okay, non-metallic character is increasing and उल्टी side कौन सा होगा? Metallic character. Non-metals we all know usually they are solids or gases at room temperature and they have low melting and boiling points. Again, boron and carbon are exceptions. And non-metals are poor conductor of electricity. They are brittle, neither malleable nor ductile. Okay. So if we are moving down the group, the metallic character increases. That we all will be studying how it is happening. So metallic character is increasing when we are moving down the group, and non-metallic character is increasing when we are moving left to right in the periodic table. So metallic से non-metallic character में change हो रहा है, right? But that change is not abrupt, all right? And there are certain elements that can be seen in between, which we call as the metalloids. सो मेटलॉइड्स में आ जाते हैं आपके बोरोन, सिलिकॉन, जर्मेनियम, आर्सेनिक, एंटीमनी, टेलुरियम, पोलोनियम. Okay, so these are called semi metals or metalloids. Let me show you here. Can you see this zigzag thing? Silicon, germanium, arsenic, antimony, tellurium, polonium. So these are your metalloids because they have some properties of metal, some properties of non-metal. So metal से जब non-metals में change हो रहा है, it's not an abrupt change. So some kind of metalloids come in between. But usually you can see, you can find a lot of metals in your periodic table. क्योंकि ये जो transition वाले हैं ये भी metals हैं. S block is metal, F blocks are metal mostly. Okay, and non-metals usually you can find in P blocks. All right, apart from hydrogen which is there in your S block. Okay, so this is about the modern periodic table that we have studied today. It was just an introduction. In our next, because you must know what is all there in the periodic table in order to understand the periodicity. Okay, so periodicity understand करने के लिए understanding of electronic configuration is also important that we have studied today. So revise this also. Try to understand which shells are filled in which period, in which group. Okay, so all that we have to remember. And in the next lecture we will be talking about the periodicity, how we will see how the atomic size changes, how the metallic character changes, then ionization energy, electronegativity, all of that. So make sure you are watching that lecture as well. All right, students, so thank you so much. We will be meeting in the next lecture.